For this post, we want to estimate an average, also called a mean, by giving an interval that we're confident that average lies within. So just to give a few examples, we could estimate the average time it takes us to get to work, or the average miles per gallon that our car gets, or the average length of time that a car works before it breaks down. Some more examples, we could estimate the mean number of steps we take per day, or the average number of times we go to the gym per week, or the average number of calories we burn or calories we consume. A couple more examples, it could be the average number of words that you say per day, or the average numbers of texts that you receive each day. So to provide an example now of estimating an average by giving an interval, I'm going to do my commute to work. My personal commute runs anywhere from 10 minutes if I get there super quick, or it's taken me up to 22 minutes at the longest if the weather's bad, if there's traffic and I'm hitting red lights and stuff. If I really thought about my distribution, which is something good to keep in mind when I'm trying to estimate an average, most of my times are running between 12 and 15 minutes. That's typically what it takes. A few times I get there faster. And then there's this skew to the right from the times that it takes me longer than expected because of bad traffic conditions. So the first step in estimating my average with an interval is to create a point estimate. This is a single number value that I think my mean is, that I think my average time to work is. And for me personally, I think if I average the times it takes me to get to work, the times I get there fast, the times it takes longer, and then the times that typically happen almost every day, the 12 through 15 minutes or so, if I averaged all those, I think the average would be really close to 14 minutes and 15 seconds. So that would be my point estimate for the mean of my commute to work. And one thing to keep in mind when you create your own point estimate is it doesn't have to be right in the middle of your lowest value and your highest value. For me, the number right in the middle is 16, but I really think my mean is going to be closer to 14 minutes and 15 seconds because these values happen a lot. And so they're going to heavily influence the mean. And then if I throw in the quick times and the long times as well, I think the long times will kind of skew the average a little bit higher than the middle of my typical day. And so that's why I came up with 14 minutes and 15 seconds for an estimate of the mean time it takes me to get to work. Now, guessing a single number like this, there's almost a 0% chance that I'm exactly right, that is my real average. And so that's the idea behind confidence intervals. If we want to have any sort of confidence in our estimate, we need to create an interval around that point estimate. So for me personally, I would say I'm about 90% confident the mean is between 14 minutes and 14 minutes and 30 seconds. So notice this interval is centered around my point estimate. That's right smack in the middle of my interval. And by giving me a range here now, I'm pretty confident that if I averaged all my commute times, it's somewhere in between that interval. Now, if I wanted to be even more confident, the way to do that is to widen your interval so that there's more numbers in it and you're more likely then to be correct that your mean really is in your interval. So I kept my point estimate right in the middle, widened my interval on both sides, and I increased my confidence that the mean really is in that interval. I want to wrap up this video by pointing out a few mistakes that I see students make. One is confusing the word average with typical. So in statistics class, when we say average, we're talking about the mean. Taking all your data values, adding them up, dividing by how many there are, and you get a single number back for your mean or your average. But a lot of times in English, we say average when we mean typical. Like I could say from this example, my average commute is 12 to 15 minutes because that's what happens on a typical day. Or someone might say, on an average week, I go to the gym 3 to 4 times on an average. That's not an average, that's what they do on a typical week. So really make sure you're calculating an average here for your point estimate rather than just thinking about typical values. And the other thing, really make sure you're starting off with step one here of creating a point estimate for an average and then building an interval around that. I'll see students say, and this kind of ties into the typical mistake, but they'll say, like, on an average day, my commute is anywhere between 12 to 15 minutes. And I'm 95% confident that on an average day, my commute is between 12 to 15 minutes. And I could say that, but I should be using the word typical because this does happen, 95% of the time, my commute is between 12 and 15 minutes. But that's an interval for my data values. 95% of my data values fall between 12 and 15 minutes. But I don't want an interval for my data values. I want an interval to estimate the average of my data values, the mean. And so it's really important just to start off by thinking about what that mean likely is, get an estimate for that, and then you can build your confidence interval around that estimate. And in this class, when we actually create real confidence intervals looking at the data, there's not going to be this sort of just guessing based off your past experience and just coming up with a confidence level. It's actually going to be based on the data, but it will follow these same exact steps. You look at your sample data, and based on your sample data, you create a point estimate for what you think the population mean will be. And then around that point estimate, we build a confidence interval. And based on our data, we can know exactly how confident we should be that the population mean actually lies within that interval.